Good evening, everyone. I'm Jinmiao from ADB. It's very glad to have this opportunity to join this workshop. Centralized air conditioning system is very common, and you can find it easily in office building, shopping mall, or hospital, and so on. Now, we are in a very difficult time. We should keep social distance and not gather due to COVID-19 crisis. The people worked in the office buildings also worry about whether the centralized air conditioning system will transmit virus. What measures should we take in addition to wearing masks and washing hands? Now, I'm going to talk about the disease resilient and energy efficient centralized air conditioning system in public buildings. Nowadays, the impacts of the climate change on people's daily life is very obviously. Air conditioning is one of the greatest inventions of the mankind. It's very uncomfortable if no air conditioner in hot summer. With the economic growth and the urbanization, air conditioning has entered households and public buildings. In 2018, the global air conditioning volume has reached 1.75 billion units. In the future, the demand of the air conditioning will increase significantly. China and India will have the largest demand. Air conditioning can bring a cool and comfortable living space, but its energy demand is huge. The energy consumption of the global space cooling accounts for 8% of the total global electricity consumption in 2019. If no action is taken on air conditioning equipment and building performance, the sharehold of the energy consumption will triple to 12% by 2070. Cooling demand in China has accounted for about 7% of the total electricity growth since 2000. Cooling also affects the peak electricity and can represent up to 50% peak loads on very hot days. A growing electricity demand is equally reflected in rapidly rising CO2 emissions, which grew fivefold since 2000 to reach more than 250 million tons of the CO2 in 2017. Most public buildings are equipped with the CAC system. We still take China as an example and find that the energy demand for central air conditioning in public buildings is increasing over time, and the rate of the increase is very large. One factor in this growth is the design of the HVAC system that requires full-time and full space operation, particularly as building design for commercial buildings has moved increasingly to central HVAC system use full-time mechanical ventilation. Energy consumption of the CAC system is large, but its energy efficiency is higher compared to a split unit. CAC system could meet the refrigeration and comfortable requirements, and meanwhile save energy through intelligent control, energy recovery, shorter running time of the compressor, and other large power consumption equipment, and so on. So the CAC could integrate with the renewable energy and powered by renewable electricity. Now the price of the renewable power is gradually declining. The energy saving of the CAC system leads investment. We need to find a balance point to maximize the economy when we make energy-saving retrofitting. The smart and the digitalization of the CAC is a direction of the future. Innovative, intelligent technology could implement group control and remote monitoring in public buildings, such as in a shopping mall. Since its good performance, the CAC system in shopping mall saves the cost of the management and makes the management more humanized. Under the COVID-19 pandemic, the CAC system in public buildings are facing some new challenges, particularly the risk of the virus transmission. The poorly designed and the old equipment of the system cannot meet the hygiene requirements in many developing countries. High density of the people in buildings will result in high risk of the virus transmission and infection. WHO updated the scientific brief on 9 July of this year. Some outbreak reports related to indoor crowded space have suggested the possibility of the aerosol transmission combined with the droplet transmission. For example, during choir practice in restaurants or in fitness classes. A commentary entitled "It is time to address the airborne transmission of the COVID-19" is released on 6 July 2020. There are 239 scientists assigned it and support it. This matter is of heightened significance now, when the country are reopening following lockdown, bringing people back to workplace and students back to school, colleges, and universities. They hope that their statements will raise awareness that airborne transmission of the COVID-19 is a real risk, and control measures must be added to other precautions taken to reduce the severity of the pandemic and save lives. It is understood that there is not yet universal acceptance of the airborne transmission, but in collective assessment, there are more than enough supporting evidence so that the precautionary principle should apply. For mechanical system, organizations such as the American Society of the Heating, Ventilating, and Air Conditioning Engineers and the Federation of the European Heating, Ventilation, and Air Conditioning Associations have already provided guidelines based on the existing evidence of the airborne transmission. Ventilation is one of the effective methods to mitigate the airborne transmission risk. Provides sufficient and effective ventilation, such as supply clean outdoor air, minimize the recirculating air, particularly in public buildings, workplace, schools, hospitals, and aged care homes, because it could reduce the concentration of the virus in the space and reduce the probability of infection. Many HVAC organizations have given some principles on ventilation. We can follow it. In the modern public buildings, a lot of the closed structure, such as glass curtain walls, are used. The ventilation of the whole building is provided by the CAC system. So the air distribution of the CAC system is very important for the various distribution. If there are one infected people in the building, how to optimize the air distribution and reduce the concentration of the virus needs to be studied. The air filter play a very important role in the isolation and the removal of the disease. Now, the CAC system generally use the filter with the medium efficiency. The size of the COVID-19 virus is very small, and the risk of the aerosol transmission. So the air conditioning filter can be upgraded with the high efficiency filter to avoid bringing virus to other clean areas. After the replacement of the high efficient filter, the resistance of the air conditioning system will increase. Whether the existing equipment can meet the needs of the whole upgrading is also a problem. Engineers need to consider it. Efficiency improvement is a big concern for the CAC system. In order to ensure people's health first, we prioritized to ensure the ventilation and the filter upgrade. So energy conservation is not so prominent during pandemic. However, as the epidemic situation moved to normal, how to ensure the indoor air quality and low energy consumption at the same time, this is also a problem we need to think about it. According to the reported infection cases, it is not difficult to find the COVID-19 epidemic often occurs in places with the poor ventilation. For the CAC system of the public buildings, increasing ventilation can reduce the infection risk, but it will increase energy consumption and operating cost. How much energy consumption has increased during pandemic, and how much health benefits for the upgrades of the high efficiency filter? It needs good collaboration of the indoor air quality experts and the energy efficiency experts to give a quantitative study and assessment. In many places, the CAC system cannot be maintained timely for the cleaning of the system, as there is no corresponding standard requirements or there is no strict implementation. The unclean CAC system has a high risk in the transmission of the bacteria and virus. Since the flu and other viruses survive more easily in low humidity environment, creating a more moderate humidity can keep us healthy. A growing consensus of the scientists suggests that the ambient humidity between 40% and 60% have few flu germs in the air and the surface, such as the skins. It can reduce the survival rates of the flu virus by up to 30%. Although many people are unaware the power of the ultraviolet light for the purpose of the combating airborne germs, but it's very effective. You can introduce the UV technology into the CAC system by installing a direction UVC light at the air mover. Some of the other measures are recommended to sanitize the CAC system, such as clean vent and register, clean air duct, clean evaporator coil, clean the surrounding areas, and so on. So another problem, the CAC, we know it relies heavily on hydrofluorocarbons, a greenhouse gas potentially thousands of the times more potent than CO2. Proper management of the hydrofluorocarbons is critical to addressing greenhouse gas emission from the CAC system. Cooling systems with the proper life cycle management of the fluorocarbons and energy efficiency features are indispensable for human health in hot climate regions. Storing and transporting food and medical vaccine supplies, which has become more evident by the current pandemic of the COVID-19. ADB is applying for a knowledge support TA to promote the hydrofluorocarbon life cycle management amount $0.75 million. In this COVID-19 crisis, the responsibility of the government directly affects the response effect. In terms of the CAC system, in the public buildings, capacity improvement is also essential. At present, some air conditioning associations in US and Japan have given some principled suggestions for the operation and the maintenance and upgrading the air conditioning systems. However, some countries, especially developing countries, have not realized the issue, or they don't know how to operate or implement it. In response to the public health crisis, it is necessary to enhance the capacity building by knowledge sharing to prevent and contain indoor virus transmission through cleaner and more efficient CAC system. ADB proposed a knowledge support TA amount $1 million to help DMCs to cope with the new challenges in CAC systems. The gained knowledge from this TA will be shared with the DMCs and accelerate economic recovery and go back to normal life. The TA will assess the energy efficiency and the various transmission risks of the CAC system in some typical public buildings. Operational process for smart automated control system will be designed in different scenarios during pandemic, resuming work, and normal situations with the digital technologies. The pilot projects will be procured through the innovation to demonstrate the benefits of the AI-enabled AC system, which address efficiency and health objectives at the same time. A capacity building and the knowledge of the relevant government agencies and public building operators on containing indoor virus transmission will be enhanced. Innovation challenge will call for proposal through ADB challenge website at the end of this year or early next year. Welcome to participate and provide your technical solution and insight. Thank you.